Okay, so this lecture is meant to introduce you to the idea of forces. Before we can really understand forces, we have to understand a base quantity called mass. And mass is just an intrinsic characteristic. Ooh, okay, that's wobbling. It's an intrinsic characteristic of an object. And that's really the best way to describe it. Like, there's no other way to kind of define it. An object just has a certain mass because, like, there's no rhyme or reason. Like, the mass of an electron is 9.11 times 10 to the negative 31 kilograms. Why? It just is. Like, you can't explain it. It just has it. Okay, so it's just something we measure. In physics, we symbolize mass with a lowercase m. And in terms of units, it's the only unit that in physics, it's a non-base unit. We measure it in kilograms, just because we tend to think of mass in kind of the macro scale. So we're looking at our measurements in kilograms. So that's one big difference between physics and chemistry. Chemistry, the base unit for mass is grams, and for physics, it's kilograms. Okay. So along with mass is a quantity called inertia, and inertia is related to this idea of mass, but it is the tendency of an object to resist change. So something with a very low inertia doesn't resist change very easily. Something with a very high inertia resists change. So for example, like a marble. A marble has a really small mass. It has a really small inertia. It's easy to change its state. So it's easy to get it moving. It's easy to stop it moving. A bowling ball has a pretty big mass, and so it has a pretty big inertia. And it's hard to just get it moving. And once it's moving, it's hard to stop it from moving. And so this idea of inertia will actually lead into one of Newton's laws. But for now, our idea of inertia is strictly dependent on the mass, okay? It's directly proportional to the mass value. We're not going to look at an equation for inertia. When we get into rolling objects, we'll look at that concept a little bit more in depth, and we'll look at an equation. But for right now, all you need to know is that the inertia of an object depends on its mass, okay? Okay, so let's now get into kind of definition of force. So force is an interaction that causes a change in acceleration of the body. Causes a change / acceleration in an object. An easy way to think of it is like it's a push or a pull. Okay, so it's a push or a pull on an object, and that force will lead to an acceleration for that object. It is a vector quantity. Meaning it has a direction, and that's important because we are going to look at if I've got one force pulling me in this direction, I've got another force pulling me in this direction, it's going to be a tug of war, and we're going to have to resolve it using vectors, okay? And for the most part, we symbolize it with the symbol F. The units, because I should have been consistent with my notation here. The units are kilograms times meters per second squared. So it's a compound unit, meaning it's a unit made up of other things. And this is equal to something called a Newton. Newton is the big guy for this chapter. We abbreviate that as a capital N. Okay, so forces are measured in newtons. Now, there are two types of forces. There are what are called contact forces. I'm just going to write here. There are contact forces. And for a contact force, it means that the objects must be touching each other in order for the force to be exerted. So examples of contact forces. This is like just your generic push, tension, like some force being exerted by a rope, friction. Those are all contact forces. So the objects actually have to be physically touching in order for that force to be exerted. And then the other type of force that you can have are what are called field forces. And so for field forces, one object has to be in another object's field in order for the force to be exerted. And in physics, there's three classic field forces. There's the gravitational force. And so if one object is in the gravitational field of the second object, we'll experience that force. And so we know that very commonly in terms of we are in the presence of the Earth's gravitational field, and so we experience that force. There's also the electrostatic force, which is a force that is looking at the interaction between charged particles. And then there's also the magnetic force, and that is a force that is looking at the interaction between two objects with magnetic fields, okay? So field forces, essentially there's two fields that are interacting, and then that force gets exerted, okay? And we will look at more specific details when we get to individual forces. So the other thing that's kind of crucial with forces are what are called force diagrams. Sometimes they're referred to as free body diagrams. I usually refer to them as a force diagram though. And this is just a picture, a simple picture that shows all of the forces acting on an object. And the relative sizes of those forces. So you would draw, usually when I say simple, we just relegate it to like a dot or a box as our object, and then we would draw arrows that are indicating the force value, and we would label the forces, and the size of the arrow would indicate how big that force is relative to the other forces, okay? This is something that you're going to do a lot. Like we draw force diagrams for this entire unit on forces because it's fundamentally how we kind of get our lens of looking at how the object is behaving because of the forces acting on it, okay? You also include the direction of acceleration. So you would just draw another little arrow kind of showing this is the acceleration. And something that is hugely important is that we should set the direction of acceleration is considered positive. And as we go into more examples of forces, you'll kind of understand why I say that, okay? So that gives you a foundation of forces, and in the next lecture, we'll look at particular types of forces.